Welcome to the fourth session of the AI Oregon 2025 Fire Resiliency Series. My name is Kurt Wilson, an AI member and architect in Eugene, and one of the members of the series planning committee alongside Jay Raskin, Alan Scott, Charles Kelly, and Logan Cravens. On behalf of our committee, we would like to thank our sponsors who you see on the screen. And we also want to thank Kathy for all of her assistance and the others in the AI Oregon staff. And as a reminder today, during our presentation, we'll have time for a discussion with Jake at the end. So as questions come up in your mind, please add them to the chat. And when we get to the discussion, we encourage people to turn on their cameras and ask their questions. This is a reminder, this is the fourth of five series program. Our fifth series is next week, the 24th at this time, and it's a panel discussion with all of the presenters, and Nate Vidasek will be our facilitator. So we're really looking forward to a lively discussion with some really knowledgeable people. So I think we're all just really fortunate to have this group and get to hear what they say. And we want everybody to join along in the discussion as well. If you haven't registered for that event, please go to the AI Oregon website and register. And again, if you haven't seen any of the sessions, you can Google the AI Oregon YouTube page and find recordings. So let's just a reminder of our continuing education credits will be on the screen. And I'm going to go ahead and talk about today's program. While defensible space and wildland-urban interface guidelines are well established for homes, recent wildfires in Oregon, California, and beyond have revealed critical vulnerabilities in commercial and multifamily buildings. This session will explore fire-resistant construction approaches tailored to large structures, addressing common design configuration, vented rainscreen vulnerabilities, and code-driven solutions. Both new construction and retrofit strategies will be considered. The session will also highlight the often overlooked risk of flooding after fire, where vegetation loss and terrain changes significantly increase runoff and debris flow. Today's presenter, Jake Kwiatkowski, brings together decades of frontline fire service leadership and federal building science expertise. He's someone who understands both what it takes to fight a fire and what it takes to design a building that can stand up to one. Jake serves with the Federal Emergency Management Agency's Building Science Branch, where he works on hazard mitigation, wildfire resilience, and building code adoption programs across FEMA Region 4. His mission is simple but powerful: to connect field experience with building science to reduce risk before disaster strikes. Before joining FEMA, Jake spent more than 20 years in fire service, serving as a fire chief, fire marshal, and emergency management specialist. He's led firefighters through structure fires, wildland incidents, and major emergencies, experience that gives him a firsthand understanding of how design decisions made in an office affect safety and vulnerability in the field. Today, he works closely with contractors, engineers, architects, and local governments to promote hazard-resistant community and community resilience. He has played a key role in advancing FEMA's building code strategy, supporting state and local mitigation programs, and aligning fire service priorities with modern code requirements. He's also partnered with state and federal agencies, local jurisdictions, and organizations like the Florida Fire Chiefs Association to bring practical field-tested solutions to the design and construction community. His focus is on turning lessons learned from real incidents into actionable guidance for builders, architects, and public safety officials. Jake is known for his ability to translate complex technical topics into clear real-world applications. His presentation connects data, design, and human element of emergency response, making the science of resilience something all of us can apply. Jake, welcome to the AI Oregon Fire Resilience Series.
Thank you, Kurt, and thank you everybody for coming. I appreciate it. I'm super excited to be here. Normally, I do all my presentations in person, so this is actually new for me to do it on Zoom. So bear with me, as I might have a glitch or two. But let me share my screen with you guys. Okay, can everybody see?
Yes, we can.
Okay. All right. First of all, thank you for that great intro. I really appreciate it. Like you said, my name is Jacob Kwiatkowski. I do go by Jake, and I'm with FEMA's Building Science Branch. I work in the risk analysis and mitigation division. Again, I was in the fire service for over 20 years, all the way through captain, paramedic, all the way up to a chief, and then fire marshal. Um, so I have a technical background and a boots on the ground type of background, which I think brings a lot of knowledge to this particular topic we're going to talk about. Because I deal with not only just residential structures but also commercial structures, and I deal with them from a lot of different angles. I deal with them from the initial build out to retrofitting for resilience. So I'm going to bring some of my wildland fire experience and my wildland fire code experience in here today to go over with you guys. Um, the Lahaina tragedy, we're going to start off with Lahaina. And the Lahaina tragedy uh, wasn't really a forest fire, it was more of an urban firestorm. Embers from the grasslands jumped into neighborhoods, ignited structures, and within hours, a historic downtown built largely of wood was gone. 2,200 structures were destroyed and 102 people lost their lives. One of the big things on that is, more than 90% of those homes were started from embers, and you heard about that in session one, and you're going to hear it a couple of times here in mine as well, because when you're talking about 90% of how a building ignites, that's pretty important. Um, the lesson there in the Lahaina is that urban design, material selection, and site planning are as critical to wildfire survival as any fire department is. And we're going to get into a little bit of topography. I know the IBHS touched on this as well, but I like this. I like this particular design because it kind of shows you exactly what the issue was. And topography is big. So when you're looking at site plans and for your buildings, it's going to be important. But for Lahaina, uh, the reason Lahaina burned so fast comes down to the wind and terrain. The town sits in a natural wind tunnel between mountain slopes, and during the fire, winds exceeded 60 miles per hour. The flames didn't chase the buildings, the wind actually carried the fire through them. Now, for architects in Oregon, once again, you're going to want to pay attention because you have similar topography. Canyon communities in Bend, hillside housing near Ashland, and wind corridors along the Columbia Gorge. Um, here's a fun fact for you. For every 10-degree increase in slope, the rate of fire spread doubles. Even roof pitches can act like microslopes, drawing heat upward under overhangs. And it's just something to consider when you're designing the eaves and soffits. And I'm going to touch on that a little bit later in the presentation about your selection for eaves and soffits. Let's keep going. NOAA fire weather mapping. One of the most valuable tools we have is NOAA's fire weather mapping systems. They're an open source of data sets that anyone in the room can access. They're not just for meteorologists or emergency managers. We use them, daily, but they're there for everyone to be able to access. Um, you know, when you're talking about as an architect, you can use them to make smarter siting and orientation decisions, long before the permitting starts. Some of the ones that I recommend starting with if you're going to do some research is the weather.gov/fire. That's NOAA's National Fire Weather page. It gives you daily red flag warnings, wind forecasts, relative humidity layers. And NOAA also has a historical model based data, and that's on the spc.noaa.gov. And I'll have links to these at the end so that you guys can access these and play with them and go through them. They're free for you guys to use. I highly recommend that if you're in a pre-planning phase or you're out doing site assessments, definitely it's worth a look to take a look at these. Another excellent tool is the U.S. Forest Service's Wildfire Risk to Communities portal at wildfirerisk.org. You can type in a zip code or the name of a community, and you can instantly get the risk layers. It'll show you exactly what the wildfire risks are for that area, the slope, the vegetation, and the exposures. It's a really incredible resource when you're advising a client on site selection and master planning. And again, I'll have these at the end of the presentation for you guys. And of course, I'm going to pitch, FEMA's building science. There is a wealth of knowledge in our building science library. More importantly, for this particular presentation is going to be the FEMA P737 and P361, those publications, linking hazard mapping to design. So yeah, there's a lot of good information out there, and the ones that I think are important for you guys here in this particular presentation, I'll have those at the end. And here we're going to go into some more topographical stuff. And again, this is way ahead of when you're going to be building, and this is so important to understand and try to get across. And I know IBHS did some in the last presentation, and I'm just going to kind of keep it going too, because the slopes do matter. When we talk about wildfire behavior, slope and wind alignment are everything. Heat rises, wind accelerates it, and narrow terrain kind of acts like a nozzle. If a canyon points towards your project, you're designing kind of at the mouth of that nozzle. It's going to act, because of the topography, it's going to act like a little blowtorch. It matters in building form, because embers don't care about zoning lines. They exploit every vent, joint, and underside soffit. In some of the California post-fire surveys, we found melted windows on the non-burn side of homes because that heat wrapped around under those eaves. And even though that one side of the home wasn't burned, it's still that heat traveling in that corridor just melted those windows. So the best way I can put it for architects and how I've kind of phrased it when I've been working with them as an AHJ is to think about fire paths the way you think about airflow and ventilation studies. It's the same physics, just with much higher temperatures. So that's what just one of the ways I kind of put it to my architects when I'm working with them as an AHJ, and it helps them kind of figure that out. So the Los Angeles wildfire cluster. You fast forward to 2025 in Los Angeles, we saw 3 simultaneous wildfires threatening multiple urban districts. The firefighters were stretched thin, meaning the first 12 hours, each building was on its own. And that's where passive protection makes the difference. That's where resilience comes into play, sustainability. If there can't be a response guaranteed in 10 minutes, resilience has to be built in to the walls, not just expected from the hydrant. Because somebody has to access and get to it. If it's more than 10 minutes, the design of the building is so important. Designing with that mindset, assuming you might be your own first responder, it kind of changes how you specify materials, access roads, and defensible zones. When I'm looking at a house or a building that's going to be designed, and we're looking in a wildfire area, we look at the topography, and we look at the NOAA information that we have, and we try to, as a fire marshal, try to help them make the best decision on where this is going to be located. And data is our friend. And so the IBHS, NOAA they are such great resources for us and for you guys. And I really highly recommend continuing to use them and utilize what they have to offer. For fire perimeters, this slide illustrates kind of how embers spread far beyond the flame perimeter. Studies showed 9 out of 10 structure losses in wildfires come from ember intrusion, not flame contact, embers. They travel over a mile carried by the wind currents, and they can enter through soffit vents, window gaps, and under roof tiles. An IBH experiment showed a single ember can reach 1400 degrees Fahrenheit. When we start designing against embers instead of just flames, the architecture becomes proactive and survivable. So as you see here on this primary ignition pathways, wind-driven embers, over 90% of that, and that's a pretty impressive statistic. Some of the other ways that we can utilize, planning and design, using dual or tempered pane glazing, protect intersections like roof to wall joints and decks, and keep gutters clear, or use metal guards. And that also goes for when you're talking about solar panels. Solar panels are generally made pretty fire resistant. The exception is when they're on the roof, the homeowner or business owner needs to work it into their annual SOPs or standard operating guidelines to go up there and remove debris, because the trapped debris is what's going to ignite, and that's what's going to ignite around there. And if we have areas that firefighters can't get to under the solar panels, or we can't forward our streams that way, it's just going to end up burning and intruding and getting into the facility. So that needs to be part, and we're talking about commercial buildings here. So that's going to fall on the facility or the facilities manager to make sure that they're keeping up with their upkeep of the roof and the solar panels, to make sure that they don't get a lot of trapped debris, pine needles, leaves up there, so that they can keep those clear, especially when it comes to right around time for a fire season. Let's switch here to the next one. Building envelope is often discussed in energy terms: air tightness, moisture, thermal bridging, but it's equally about ignition resistance. A resilient envelope manages heat transfer and ember resistance simultaneously. FEMA's data shows that every $1, and this is important when you're going to pitch things to your builders, is that every $1 spent on resilient construction saves $11 in future loss. When you design for wildfire, you're not just protecting a structure, you're protecting continuity of business, housing, and the like. IBHS did in Paradise, California, the homes that were built to IBHS standards, wildfire standards, had a 51% survival rate compared to just 18% overall. That's not coincidence. That's just design science, and that's why you guys are at the tip of the sword when it comes to resilience and design. You have the ability to tell them why it's important, and you have the ability to show them the prices and where they're going to be able to save. And again, this picture here just goes to show you that not only is building resilience and wildfire resilience important, but it can look good, and it does. Strengthening roofs, walls, windows, and doors not only protects structures, but it also enhances community safety and speeds up the disaster recovery. Because yes, there may be some damage, but when it comes to working the building and fixing the building, when you have these elements in place, it's going to end up with a quicker getting the business back to work. And that's just a picture of cladding. Rooftop resilience strategies. The roof is a primary ember landing area. We all know this. And the pictures that I have up there are, um, some of the roof coverings and the ridges and penetration and flashings. Um, it just goes to show that's too big of an opening. It's greater than 1/8, and then the one below it with the green check mark shows you what it should be. That's ember resistant, so it can't get it. The embers won't get in and intrude there. Um, the roof is the primary ember landing zone. So we always want to use Class A assemblies with sealed penetrations and non-combustible materials. Uh, Metal or tile roofs perform the best, but even asphalt can work if it's properly flashed and maintained. And again, when you're talking about commercial buildings, that falls on the facilities manager again to make sure that that is all maintained. Um, in Malibu, I'm going to use this as an example. In Malibu, one commercial block survived the wildfire because of metal roofs and 12-inch parapet caps. The block next door didn't. Same wind, same fire, just a different design. And that's why we're here, and that's what we want to put upon you guys, is to continue to make these design choices that are appropriate. And unfortunately, with the most recent fires that have happened in the recent past in January, Lahaina, it has really come to the forefront. And I think not only for designers, but for everyone that's at FEMA and at the IBHS, these were really something that brought things to the forefront and resilience in these areas to the forefront. And so I really appreciate the AAI bringing this to you guys and really getting some information out there. It's really, really important. All right, I'm having a little issue here. There we go. Wait, let me go back. All right, sorry. My of course my clock started running. Rooftop detailing and vulnerability points. Um, Flashing transitions are common ember entry points. We're gonna, and I'll touch a little bit more about this on the code later on in the presentation. Skylights and penetrations require sealed edges and non-combustible framing. Aluminum is the best. Some wood is okay, but if you really want to get to the Class A, it's going to be aluminum. Gutters and scuppers collect debris, which are ignition hazards. Ember resistant vents, less than 1/8 inch mesh baffled. And those were the pictures on the previous slide that I had previously showed you were the vent screens. For FEMA, we're always talking about short overhangs, box soffits, and non-combustible fascia. And if you go to FEMA P737, you can see that in our publication. And it's just another way of we just have to keep the embers out of that building. If we can be resilient and keep them out of that building, the better off the building is going to be, and your percentages of that building surviving go up. Okay, this is local adoption and best practices in Oregon. Oregon's been advancing wildfire codes through ORSC R327 and the International WEI code. I know that in 2025, the hazard map repeal, is there, but you guys still have, you have the opportunity and the authority to design to higher standards voluntarily. I recommend you touching base wherever you guys are going to be building, or you have projects going on. Touch base with the AHJ and see how they are. It should, the AHJ or the fire marshal, because they will know and have the specifics on the way they want you to build. I, as an AHJ, and a fire marshal, I loved the process. So I loved working with The architects, they knew that they were welcome in my office, and they would come by. We'd have coffee, we would talk, we would just go over things. I know that not all HJs are that way. I understand that, and it has been told to me on numerous occasions that I was the outlier when it comes to things like that, and I was happy about that, because when it comes down to it, we're all trying to work together. And if you guys ever run into a fire marshal that is giving you some issues, feel free to call me. I'm in the Fire Marshals Association, and I will be more than happy to talk to them and see if there's anything that I can do for you, or just make it a little bit more personable. Um, I'd be happy to do that for you. You have my information, and you'll have it on the slides as well. So feel free to give me a call anytime, and anytime you have any issues, just I'd love to help you guys out. Getting back to it, sorry, I need to get back to this, but the International WUI Code is a model for ignition resistant construction. ORSC 327 provisions remain the best practice reference. And I realize that these are for, it references residential. But when you're talking about a multifamily or maybe a multi-business project, something that's overhangs or decks, it still comes into play. So you guys can still utilize this code for those, because for those decks, that are over 200, we want to make sure that they're Class A, and that they are non-combustible. And again, architects, engineers can drive the adoption of resilient design locally. It's if your customer is okay with you designing it to wildland fire standards, then design it to that. There's going above and beyond is not a bad thing. That's actually a good thing. And there's some references for you at the bottom here: ICC, IWUIC, and I'm sure you guys have the ORSC code, and NFPA 1144. You can find some information on it in wildland fire there as well. All right, here's where I can basically sum this up quickly when it comes to building code standards for commercial and multifamily buildings. Zone 0, we're going to talk about defensible space design and Zone 0 based fire protection strategy. Zone 0 is the non-combustible materials only zone. No vegetation, mulch, or flammable decorative elements. No shrubs, no mulch, but you can design it to make it as pretty as you can, but just keep those areas 5 feet away from the building. That is one of the most important factors when it comes to this, is that Zone 0, when you're talking about commercial buildings. When I talk to architects and designers, that's the first thing I talk to them about. There's areas in Tallahassee and Ocala that are large wildland fireland areas, and we like them to build a code to this code for that specific reason. The less we can have burn near it is what we're shooting for. So this Zone 0 is by far the standard when it comes to this. Then you're going to move out a little further. You'll see Zone 1, which is 5 to 30 feet, and that's going to be your fire-resistant vegetation. Let me get rid of this here. And with the strategic spacing and low fuel loads. So again, you can put your trees that are, slightly fire-resistant, vegetate in some vegetation. Zone 2, reduce fuel zones with selective vegetation management and fuel breaks. So here's where your parking lot comes into play. Here's where your, if you're designing a residential home, here's where your driveway and your road leading to the house come into play. Design those, and you can find this in the IWU WUI about their driveway spacing to act as a fire break. That is going to be a defensible space design, and it's one of the best designs that you can have when you're talking about residential and somebody that's going to be building in an area that's prone to wildfires. Defensible space is their friend. All right, here's more of the zone critical requirements. The 5-foot zone non-combustibles, and we're going to be building with exterior walls classified as type 2 and type 3. They require non-combustible exterior walls constructed of brick, masonry, concrete blocks, and precast panels. The precast panels are getting better and better every day, and they're really becoming a key player in the aspect of wildland fire and construction, because they can honestly make them look, in the previous picture that was shown, you can make them look as decorative as possible to give that building a really good feel. Um, for commercial and multifamily design systems, the principles still remain the same: non-combustible balconies, back ventilated wall systems, screen mechanical intakes, and side access. And this goes back to the parking lot and the driveways to make sure that they are defensible and act as fire breaks. And this again is IBHS, and again I like to say they're amazing, and the testing that they do is phenomenal. Okay. So we're going to talk about multifamily building risks, balconies, and ember traps. That's what a balcony is. It's an ember trap. When the embers are blowing, and they could be blowing from a mile away, that's where they're going to go. And this goes to show, this particular slide is showing you the differences in the how fast they heat and how fast they go. So aluminum decking, non-combustible decking is by far the best, obviously. Composite decking is your next best, and then pressure treated wood. So you're going to want to utilize those. This slide here gives you some idea of time to ignition in minutes and the burn through time in minutes. So as you see, aluminum and concrete, there is none. They prevent ignition entirely. And then traditional wood and pressure tested and composite decking. You can see in composite, time to ignition is a little over 6 minutes, but the burn through time takes almost over right at 18 minutes. Cedar is going to ignite within less than 3, and then it's going to burn through in 6. So, we really want to stay away from those wood decks, because that ember gets on there. And again, like I said, it's 1400 degrees. So it's gonna make them catch quick. So commercial and multifamily specifics, enhanced requirements, and this is for the larger buildings. We're going to touch on that balcony design, because if you're going to build in balconies, they need to be non-combustible decking and railing systems, metal or concrete construction with drainage to prevent ember accumulation. This way that if they do have a balcony, they can continuously clean it and not have any buildup. The wall systems need to be back ventilated, and rain screens require fire blocking in each floor. Continuous insulation with mineral wool preferred for their fire blocking. HVAC intakes with ember screens for the mechanical systems. And we generally want emergency shutdown capabilities during fire weather warnings, because if the outside, even if we're not having ember intrusion, if we leave the HVAC and the mechanical systems on, the smoke that's around the building is going to start flowing through, and that's going to be another dangerous hazard for life safety. Site planning. Always the site plans. This is another area where the HJs take a big part of, and that's the fire department access, the turning radius, and the hydrant spacing per IWUIC Chapter 4 and 5 requirements. And we want that spacing to be enough to where not only we can get it, but they're enough feet apart so that they're not on top of one another. And so we're going to come into an economic case for fire resilience, and this is what I use when I go out to communities and we're talking about bringing on building codes. and I get to sit down with the builders and have a nice, calm discussion about why uh, resistant building codes are a necessity. And I start talking about building resilience and why building resilience is so important. Um, because when I look at it, when you're talking about a 2 to 4% in construction premium, but overall you're going to have a 3 to 1 cost benefit ratio. That's for me, that's an easy sell because um, that's what you want. You not only want a building to be resilient, but you want it to last, and you want it to be a benefit when it comes to a cost ratio. And not only that, when we're talking about wildland fire, we're talking about insurance savings. And right now, in some of the PRAs that I've done, the resiliency assessments, insurance is the player right now. It is um, probably one of the biggest issues, especially here in Florida, but as well now in California, and I'm certain in Oregon, in the wildland fire areas, that it's becoming an issue. That these insurances, they're going up. So if you can save that money from the very beginning, even though that upfront cost might be 2 to 4% more, in the long run, you're looking at 15 to 20%. And when I close, I'll have a little script you can use. So if you get some pushback, you can kind of use a little script that I use when I go out and help, because when I go to a community, it's not that I'm just meeting the community and the leaders of the community, but the builders that build in that community are there, the contractors are there, and so they all want to know what's going on, because this is cost to them, and they have to pass it on to their buyers, and that's a big concern to them. So I welcome that conversation, and I welcome showing them how being resilient can save. So again, the building code implementation standards. This is just a touch on some of the things that you can utilize and use for your codes. The IWUIC 2021 International Wildland Urban Interface Code. Great product and great use. California CBC Chapter 7A, Materials and Construction Methods for Exterior Wildfire Exposure in High Risk Areas. Again, NFPA 1144, it's hazard assessments for your new commercial multifamily projects, and our FEMA publication P737. That's another one that's specifically for wildland urban interface and construction practices. Time here. I want to leave plenty of time for questions. This is just a code requirements quick reference. This is something that I kind of put together for you guys. Exterior walls and how each of those publications classes them. Roof coverings. NFPA uses fire retardant. The others use Class A assemblies, Class A materials. NFPA 1144. There are I know a few AHJs that are writing changes right now to that, but it's still in the works. But they have it listed as protective openings. We're going to go to the no less than 1/8 inch mesh max, and that's working now. So that will change eventually. California is ember resistant, which again, when you look up ember resistance, it's going to go less than no less than 1/8 inch mesh. Decks and balconies, pretty much relatively all the same. Ignition resistant. 7A says non-combustible. 1144 says fire safe materials. Defensible defensible space. Buoy is 30 to 100 foot zones, and those are broken into three. California Chapter A is a zone zero is required. NFPA 1144 wants you to do a risk assessment, and then once you do the risk assessment, then you can judge which zone you're going to be in, 0, 1, or 2. Access roads, here's a great one. WUI is 20-foot minimum width. In our fire department, where I was an AHJ, we had 25. And Chapter 7A for California is emergency access, and that's going to, if you look up Chapter 7A, they'll give you the definitions of what that actually entails. Then I'm going to touch with you guys from being from Oregon, some Oregon building code and wildfire policy. 455612 requires wildfire hazard mitigation standards for new dwellings. R327, it's wildfire provisions. And I have that pulled up. I can share that here in just a second. 629044 defines WUI hazard zones, low, moderate, and high. And then, of course, your 2025 repeal removed the statewide hazard map and mandatory application, but that doesn't stop local jurisdictions. So again, I recommend touching base with your specific AHJ for the community that you're going to be building in, and he will have the standards that they are going to reference. And these are just the references: Oregon BCD, the ORS, and the Ballard Spar legal update. Here's some references and data sources that I have. And I have a handout that I can share too as well that has some more on it. With the IBH research, just look up the Lahaina configuration report, the deck ignition testing, and their wildfire prepared neighborhood standard for 2025. FEMA is always the P737, P754, and wildfire technical job aid. In your government agencies, your code organizations, and again, the photo credits. Hawaii, I got some of their photos, and NOAA satellite imagery. That's my contact information there, Jake at stlwestco.com. And that's my number, 314-378-2411. Feel free to give me a call anytime you guys need anything or have any questions. I'm always happy to help. I enjoy learning, and any conversation that I have, I always learn something new, and I just enjoy it. So please feel free with any questions that you have. Feel free to give me a call. And I have some anticipated questions and answers that I'll put out in the chat. I think I'll probably put them, if that's okay. And let's see, go here. Kurt is up, and
Yeah.
And then I just wanted to, Kurt, before you get started, can I just give a quick, here's what I wrote this up for you guys as a pitch that you can use when you're, making your case for resilient design. Because it's a chance for you guys to lead with design that doesn't just be coded. It can outperform it. Resilient buildings protect more than the structure. They protect occupants, operations, and reputation. For your clients, developers, property owners, municipality, that means fewer disruptions, lower insurance premiums, and faster recovery when disaster strikes. The numbers speak for themselves. Every dollar spent on resilient design saves an average of $11 in avoided future loss. For every dollar spent, $11 saved. And that's according to FEMA's mitigation assessment team studies. And you can go to FEMA's building science branch, and it'll say it right there on the very front of the website. It's 1 for 11. Wildfire resistant construction only adds 2 to 4% to upfront costs, but it can reduce damage by 40 to 60%, which is significantly lower than insurance exposure. For commercial portfolios and multifamily developments, that resilience also translates directly into better insurability, higher property values, and stronger tenant retention after regional disasters. Think about it. In a competitive real estate market, resilience is becoming the differentiator. Owners and investors are beginning to ask, can this building withstand the next event? And that's why PRAs, primary resilience assessments, are becoming part of the standard when you're doing your speculating. And what the resilient design offers is offering stability, credibility, and risk reduction. So when a client hesitates about the cost of ignition-resistant siding or non-combustible decks or fire-rated venting, remind them, this isn't an expense. It's insurance that pays you back. It's design that proves its worth when everything around it is being tested. And ultimately, those are the buildings that define your legacy. You want to pitch that to them and let them know that's what they want to look at. So I just thought I would throw that in there, help you guys out.
Jake, that's great. I really appreciate that. I think having as much data as possible in that, and struck me the slide that compared the cost savings and a couple bucks a square foot versus the insurance premium savings. Mm-hmm. And I think if we move forward, we're all going to be feeling more impact from insurance. just as we have more fire, that seems like a really important one. So I appreciate
Yeah.
your comments.
And it's important for architects to have that kind of in their toolbox so that
Right.
when they come across these issues that they're able to use that and be able to show exactly percentages and numbers on how much you can save and how much it's going to cost.
Right. I appreciate that. I'll throw out a question here, and then Logan's got a handful that I think would be a good discussion on the zones and landscape items. But you provided really good information, some clarity, as did Evan from IBS on just the screen size, the 1/8 inch gap or smaller. And what I'm finding a little bit of difficulty in finding products like a soffit board and other products that have any published information about their screen sizes, or if you're getting a screen vent, it may be difficult to add a screen of that size to it. So I'm curious if you're aware of any product standards or any kind of labeling or any other kind of testing that incorporate fire resistive standards in some kind of a rating system, so the product would have a fire ember resistant standard that could be applied. Are you aware of anything that's happening across the country in that regard?
So what I'm finding is that they all are kind of falling back on WUI and what their recommendations are for the wildland urban interface. NIST is currently doing some testing on what they're going to be considered fire resistant sheeting and protections for vents. So as of right now, I believe that they're just utilizing the standard, less than 1/8 inch mesh opening. Now, when you're talking about someone that provides that, the schematics that they're going to provide should be entailed in there with what you're going to buy, and their rating and their testing that went along with. Just like if you get a nozzle, a sprinkler nozzle, it's going to have that same testing information along with it, and it should have that. But what you're going to find is that it's going to reference the WUI standards, especially if it's made to that standard.
Great.
And then
Logan,
there was a
go ahead.
question in the chat that I wanted to talk about how the federal layoffs and budget cuts affecting NOAA's real-time hazard mapping. It's not as of right now. It was going to as of the day before. But there was a judge did an interjection and stopped the layoffs. And so it's still going. We're okay there. So no worries on that particular issue. As of right now, I mean, this changes daily right now. So it's, right now it's good. That's all I can say.
Yeah, tough situation to be in.
It
Logan,
really is. It is. I'll just leave it at that.
Logan, you got some good questions here. Why don't you ask questions?
Well, I'm not a landscape architect, so I was wondering, are there specific references that actually rate fire resistance plantings?
There is. There are. You can. Oh gosh, I wish I had the website right here in front of me that I utilize when I look at them. I'm sorry I don't, but there's a website you can look it up that will give you the ignition temperatures, and it will also give you what they recommend for the 0 to 5 foot zone, as far as what you're going to want to use once you're outside that 5 foot zone. Obviously, anytime in between there, they're going to want you to put nothing, but there are specific plants, and even if you go out to the zone 1, they're going to be considered a zone 1 rated tree, because that's generally, once you get out of the 0 to 5, you're going to get into that zone 1, which is going to be basically parking lot and medians in the parking lot. So that's where you're going to want to plant either the shrubs, or generally most people put the trees. They're aesthetically a little bit more pleasing, but they are. I'll get this website to Kurt when we're done here, and he can put it out in the chat, that shows the fire ratings for the plants.
Hey, thanks.
No problem.
Kind of related to that is in a residential area, and I'm looking at my own property. Zone 0, that's fine. We can clear that out. But
Right.
we get to zone 0, I'm at the fence of our neighbor. Our neighbor's got a huge, you know, maple tree or
Right.
cedar
Yeah.
tree.
It's funny, I live in Florida, but Florida is still prone to wildfires. We get huge droughts, and I mean they get going and they go good. Um, we have a lot of lightning in this state, so we get a lot of lightning strikes. And then where I came from to Florida was in county in St. Louis, Missouri, uh, which was called Wildwood, and it was a area that, for whatever reason, they think it was because of the clay in the soil, was very prone to lightning strikes. I can't tell you how many fires and homes that I went to there because of lightning strikes. But when there's a drought, lightning's going to get it going. And so yeah, it really comes into play when you start. When I was doing residential HJ work for my community, that would come into play, especially in the higher plains areas of the Florida area, because once those planes get going, they're going to go. And again, we're talking about embers traveling over a mile. So those kind of zone 0, zone 1s would come into play even in residential because of the issue. So if you live in a residential area that's prone to wildfires, or I would definitely take a look at it, and see what you can do to assist for sure.
Alan's got a question in the chat about rain screens, and I have a similar question. Mike, you had mentioned, and Alan, I can have you ask your question. My question about rain screens and the fire blocking at floor levels, from your perspective as a fire marshal, do you consider the fire blocking requirements in the code, which are typically applied to the framing cavity, does those same provisions, in your opinion, apply to the vented screen of the envelope system?
So each jurisdiction is going to be different. Okay. Each fire marshal is going to be different on the way they want you to fire stop. Okay. Um, so to answer your question, yes, I
Okay.
want it exactly like that. But when I'm talking about for the base, I use fire resistant. I'm okay with fire resistant caulking, but not when we're talking about rain screens and, the single floor segment and the vented top and bottoms. I agree with you 100% there, the cavities. But for just floor, electrical intrusions that come through the floor, the fire caulk is what I like. It helps builders because it's not less expensive, but it's readily available, and they can utilize it. And so when I do my inspections, when I do my frame outs, I walk through and I check all of that. So yeah, but you're exactly right. That's the way I do it. Now you're going to run into people that may want something else, or their code, the way they do it in their community, their code calls for something different. So I always recommend talking with the specific HJ where you're looking, but for your answer, yes.
I mean, I'm curious if other people have different experiences, but I don't have a lot of conversations with either plans examiners or inspectors about, treating that fire blocking in a multi-story screen system.
Yeah, right.
Yeah. Alan, you had a question about screens.
I think I know the answer to this, but I just wanted to be absolutely clear and independent of what the local fire code is that might need to be prescribed in terms of best practice. Is there any issue with having those single floor segments of a rain screen vented top and bottom, and so you've got a top vent right next to a bottom vent as long as you have a fire break in between them? Is that
Correct.
There isn't, from a best practice fire prevention standpoint, an issue with the venting part of that?
There's not really a venting issue with that, but you still want to have the fire breaks and how it's constructed so that it's to code. So that's not really a issue that now if you go against the code and you don't have your fire breaks and you design it like that, then that's going to be a huge issue. But if you design it with the fire breaks and you're doing your designed so that it matches the AHJ and what they want, you should be good.
Jake, you mentioned,
I think, and I was just going to touch on the other issue. I think that the non-combustible insect screens at the bottom is also a really important element. But can you speak at all to the issues about the type of insulation that's behind that rain screen? You know, you've got a non-combustible cladding, but then you might have you know, a foam-based insulation as opposed to rock wool. You know, how much of a
Right.
concern is that?
And the foam bases are getting better, as we know. We still like the traditional rock wall, but you know, again, that's going to be a AHJ, you know, call because it's in the code book. So it's going to be up to them in that particular community what they want to use. They give them leeway in the code to what they prefer because it's all been tested. So you know, everyone's different. Well, I don't want to say that everyone's different. They all follow the code, but their choices when it comes to that could be, you know, their regular rock wall or foam. I personally, it's getting the foam areas or the fire resistant foams are getting better. I still like traditional ways that are clear cut and have worked, in my opinion. But I'm still open and love to read the science behind each one that's coming into play. So, and as they put them in the code books, then so be it.
Thank you.
that's great. You know, before we're almost at time, but before we wrap up, Charles has a question about mapping, and I think there's some also. I had a question about mapping as well, but Charles, you want to turn your camera on and ask about your mapping question?
Yeah. Yeah, I just found the resiliency analysis and planning tool on your FEMA website that
Mhm.
tends to give you you can pick out what the hazard events are
Sure.
and you can set it to fire and you can see, and it just seems like that's a good tool to put forward as an organization as through the AIA is to give people a sense about how to deploy some strategies in different areas based on the risk. But I noticed that the risk is measured by what economically is at risk, like what could burn.
Mm-hmm. Mm-hmm.
Um, and is that how do you nuance how we talk to people about the risk? Is it on what the total loss is economically, or is it, I mean, when you go forward with the question of resilience, are you leaning on the social side or the economic side? And is there a way to draw some conclusions and looking at the map through an economic lens?
Sure. So we look at both. We look at community, and we look at the building in particular, or what is going to be built, and the sustainability. Ultimately, what comes into play is the map itself is there as a tool to use so that you can kind of pre-plan for what you're getting ready to utilize or what you're possibly looking at. Oh, thank you for putting that in there. What you're going to be utilizing, the whatever the land or building that you're going to be using. But the ultimate, what it falls back to for you guys, and I'm sure when you're trying to get everything together for someone and make them understand the resilient side of a building, is that, you know, the upfront costs and the savings overall. Our map is going to be to assist you with that, right? You can take the data that's there and utilize it towards your project, and to kind of give you a visual of what's going to possibly be some of the ramifications for the resilience. It's going to be a case by case basis, obviously, on what you're building, what you're spending, and where it's being located. But the map is part of a process that you can utilize to make a more educated and a definitive decision when you're looking at where you're going to put it.
So it's sort of like process of the cost benefit of analysis and all the risk that you can hold, given your income level, all the things that you would put into play, and how much
Right,
risk
and
you'd expose yourself to.
Sure, exactly. And if you're talking, well, and it could come into play as well if you're rehabbing a building, right? Because if you're going to go more than 50%, you're going to look at the new building code standard. So, that's going to come into play too if you're going to be doing a more resilient building, and you're going to be doing over that standard, you're going to have to come to the new codes, which are inherently resilient. That's what I'm doing right now. So, yeah, that cost is going to come into play. And a lot of times what I'm seeing in the things that come across my desk is that the, freestanding buildings that are already there, the cost is really to make them more resilient is getting up there, to the point where people are, working on whether it's more cost effective to tear it down and to build the entire building just to the new standard, because of cost. So
Sounds like we need architects. Appreciating your plug there for us. Thank you so much.
Without question. And I had my own rehab business. Every fireman has their own business, right? So they have a lot of time to do stuff. So I rehabbed houses, and I had an architect, and I can't tell you, and that's why I wish every fire marshal had done construction in the past, because if they had, I think they'd be a lot more amenable to working with architects and builders. But I had an architect on my staff, and he was just fantastic. I utilized so much information that I utilized him for, and that's where I really got my start in this business. Was doing that side business. I was a fireman, and then just doing that. So,
well,
yeah,
thank you so much. Thank you so much.
Yeah.
You guys are amazing.
Lyndon, you had your hand up for a bit. And you're still there. You have a question?
I do. Quickly, I know we're close to time. I was just curious if you're aware of any sort of like code chatter about combustion products and building materials, like we were talking about foam. And as first responders probably don't prefer foam. So that's probably another plug for mineral wool.
Yes, that is true. These are being tested as we speak, right? The chatter is that because they are so cost effective, right? And it's a easily utilized money per square inch of this product is so beneficial, that we have to start taking bigger looks at it. And again, I'm old school, but as long as I have the science, being in building science, if I have the science, which they are working on with a number of different products right now, I'm okay with it. Here in Florida fire marshals are old school. Okay. We don't particularly care for, well, not me personally, but a lot of them don't particularly care for that, for the new type of foam. And I was mentioning fire caulking. A lot of them won't even utilize that. They don't, they want the standard, block, fire stops. So we're working on it's just a science issue. It's seeing how long it takes them to burn. What are they off gassing? Is it biodegradable? Right. So there's a lot of variables that go into that when it comes to that. And NIST, I know, is working on some of those things right now, and I'm looking forward to seeing what those are going to be, because for me, when it comes down to that, is if there is a building on fire, even if it is sprinklered, is that foam off gassing? What is it off gassing? Those are the important factors for me as a firefighter and a fire marshal. Those are the important factors for me to know. What is it? What is coming out of that? Because if fire touches it, yes, it may be holding off the fire from penetrating to a different area, but what is it releasing that could be getting into that ventilation? So that's where my head is when I think about that kind of stuff. Sure, it works, but I think about the other gaseous factors.
Yeah, and that's just part of the more holistic thinking.
Right.
Going above and beyond code is
Mm-hmm.
you make those
Exactly.
choices.
You are correct, 100%.
Thank you.
Right. All right, last one. We got a question from Malin in the chat. I'll go ahead and read it. It says, for buildings that have vertical louver openings to bring ventilation to unconditioned attic space, would the 1/8 inch mesh still enough to prevent embers from entering the attic spaces?
Yes, and it's in my ventilation louver right now in my home.
Okay, that's great.
So, yes.
Great example.
I'm not in a prone area, but I'm a fireman, so any type of thing that I can do, I do. So yes, it's in my louver right now.
Great, great. Well, thank you very much, Jake. I really appreciate your time, and just recognize that for everybody here, Jake's in Florida, so he's wrapping up at 4 o'clock. So appreciate your giving us your Friday afternoon.
No
That's
problem.
wonderful. We will be, Kathy will be sending out links to the presentation document and any other documents that we have from Jake early next week. And I very much encourage everybody to register for the panel discussion, and hope to see everybody then, including Jake.
And I'll be
So-
there, and I'm going to bring my information to put in that, and that way everybody will have it. Just in case you don't send it out, I'll have it for the follow-up, the wrap-up.
That'd be great too. I really appreciate that. So,
No problem.
all right. Okay. Thank you, everybody. Have a great rest of the day, and have a great weekend.
You too.